Okay, this is the second day of trig ratios. You're going to get a different type of problem today, so I'm going to show you a couple of examples so you can come back and look at them. Your directions today are going to say solve for triangle. Let me tell you what that really means. It means anything that's not given, you got to figure it out. So there's a lot of stuff up here that's missing. So what I want to go through is show you how you're going to have multiple answers, okay? We got to find the measure of angle y. We know the measure of z, that's 90. You don't have to figure that one out. They only give us one side. So our job is to find these other two sides. So I'm going to show you how to begin this problem. And I wrote here so that when you get ready to do these, you'll know what it means. It means you got to find all the angles and all the sides that are right here. So here's where we are. They start off with the angle measure for x and one side, which is the hypotenuse. Let's go label it. Let's go ahead and label the other sides. That one's opposite when you're looking at this guy, and this one would be adjacent. That's going to help us in a few minutes whenever we get ready to use those other sides to figure out this answer. While I'm here, remind yourself that you can call this little side little x and this side little y. Alright, remember you can do that. That may help you when you set up equations to solve. Okay, so I'm going to go solve for x first. It doesn't matter which one you solve, by the way. So, if I want to start using this angle, this side, and that x, that means I'm using opposite and hypotenuse. So that is sine of 39 degrees would be equal to x over 7, right? Now, I'm going to show you how, we will use our calculator, but there's some algebra here that you got to do before you go to the calculator. We want to get x by itself, so we're going to multiply both sides by 7. So there's a little algebra there. So you're going to need to put this in the calculator. Just like this. I want to warn you about, if you put the 7 on the back, that could be misleading because the calculator might multiply 39 times 7 and then do the sign. So I like any multiple to be out here in the front. So watch me when I go to my calculator. So 7, and then I'm going to do sine. And this time it's regular sine because we know the angle. And it was 39 degrees. Notice I closed it, and I'm getting 4.4. So, by the way, I think your book will let you do one decimal place. Yeah. So, we're going to also round. We're going to say x is approximately 4.4. So if you want to come back, you can put the 4.4 just to remind yourself, hey, I got that side. Now I got to go get another side. Okay, so if we're going after y, remember we still have the hypotenuse, we still have an angle. We could go use cosine because it's adjacent and hypotenuse. So here, I'll just write it over on this side. So the cosine of 39 is equal to little y over 7. So it's going to work a lot like this one. So again, multiply both sides by 7. Then go to the calculator and get that answer. So I'm going to do 7 times the cosine of 39. 5.4 for that side. So we're getting close to having everything done. What's left? We got one angle up there, right? Because remember, that's 90. You never have to figure that one out. We got to figure out this one. Let me show you a quick way to do it. These two angles plus the 90 have to equal 180. Well, here's a better way. These two have to equal 90. So you need to do 90 minus 39. And we get 51 degrees. So I'm going to say angle y is 51 degrees. So here's the missing pieces. The measure angle y, little x, and little y. Whew, that's a lot. So when it says solve for the triangle, it doesn't mean one answer. It means go find all the pieces that aren't up there. Okay. Let me do one more. These are kind of long. Sometimes this problem actually had the hypotenuse, so we were using the sine and the cosine. I think my next problem doesn't have the hypotenuse. So, we'll see how this one goes, because it's not got the hypotenuse within it. We do have a measure of one angle. At the end, we'll figure out y, measure angle y, that'll be easy. But let's just keep what we've got right now. So, let's label it. Way over here, this would be the opposite. I'm also going to go label those sides. This is little z, okay? He'll be the hypotenuse eventually. And then little y. I might want to do the tangent on this one. I'm going to do the tangent of x, which is 47. Remember, SOHCAHTOA, TOA is opposite over adjacent. This is opposite, this is adjacent. So it's 16 over y. Okay, when you do this one, what I want you to think about doing is to get this y by itself. It's going to be a weird kind of thing, but I want to put it as a proportion. I'm going to cross multiply, and I will get this equals 16, because this times this, and this times this. But to get the y by itself, you're going to divide both sides by the tangent of 47. So what we're going to do in the calculator is 16 divided by tangent 47. So let me show you how to do that one. So put in 16 divided by, and I'm a little conservative when I do this. I like to put a complete big parentheses around the tangent of 47. Guys, you gotta realize tangent 47 is just a decimal. It's just a decimal. But I need to do 16 divided by that decimal. And then here it comes. 14.9. So we're going to come back and say that side is about 14.9. I'm going to put this up here, and I want to mention something. You all remember from the Pythagorean theorem, this measurement should be bigger than both the other two. So we'll get to kind of check our answer and make sure it makes sense to us. Okay. Now, to get z, it is the hypotenuse, so I need to go back to either sine or cosine. I am probably going to go back and use sine. Let me tell you why I would use sine. I know I could use cosine because I just figured out my adjacent side. But if I'll stick to what they gave me, then if I'd made a mistake on that, I can still get this part right. Okay, so it's all right if you want to use cosine and use the 14.9 over the hypotenuse. But I'm going to go back and use sine because they gave me this one and I'm trying to find that one. So sine 47, opposite over hypotenuse. So this one, same sort of algebra going on here where we're going to, what really happens if you want to see a shortcut, they flip-flop. You see that? Remember down here, see how it was right underneath? So that's a shortcut. I'll do it the long way, but I wanted to point out they're really just flip-flopping. And so your tangent's down here and your y's back up here, which is what you want. You know, you want your variables to equal all that stuff. So what we're going to do, cross, and then divide. So in the calculator, do this with me. Sine 47 needs to be divided into the 16, but be careful, and I like to use the parentheses around it. So 16 sine 47. 21.9. Okay, so Z is approximately 21.9. Is it the biggest of the three sides? Yes, it is, so that sounds good to me. All right, last thing. Jamie, have you figured out angle Y?
I can. It's 43.
43, good. So angle Y is 43 degrees. How we did that, these two together have to equal 90, so we're doing 90 minus